So the next thing I want to do is figure out what the graph of the cosine function looks like. And I could do this using the same kind of procedure, right, that we use with the sine function. Think about maximum and minimum, where are the intercepts, and so forth. But we can also get at this by using this cofunction identity and just doing some transformations. Right, so let's see. First, let me just sketch the sine function on here. I'm going to go from 0 out to pi, out to 2 pi, and I'm going to use the same kind of stretch. If I tried to draw this just going up to 1, the graph would be very, very narrow. So I'm going to just distort the axis a little bit and say this is pi over 2 comma 1, and this is 3 pi over 2 comma negative 1. And then our graph keeps going, right? So let's see, there will be my next intercept, and the minimum value is here in the middle, and let me get just a little over here. There we go. Okay, so let's manipulate this a little bit, because remember, to do transformations, to do side-to-side transformations, it has to be x plus or minus something. All right, so let me rearrange this. Let me make this sine of minus x plus pi over 2. And then I'm going to factor out a minus sign. Sine minus x minus pi over 2. And finally, I'm going to use one of my sine identities. I can bring this sine out in front. This is minus sine x minus pi over 2. All right, so let's think about what happens then. X minus pi over 2. That shifts the graph pi over 2 units to the right. Right, so this point here gets moved over to here. This point, the x-intercept, gets moved over to here. And this point here, the minimum value, gets moved over to here. And that's kind of enough, right? I think I can get this now. It's going to go like this, and then it's going to come back down, and then it's going to come here, and then back up. Okay. So the green, let me write it in here. The green is y equals sine of x minus pi over 2. All right, so now let's get to our final answer. Right, I got to put that minus in. So cosine of x, this is my final graph, equals minus sine x minus pi over 2. Remember that minus sign, that is a reflection across the x-axis. So that's just going to flip the graph over. This point that was up here at positive 1 is going to go down to negative 1. And this point that was at negative 1 is going to go up to positive 1. And the intercepts, they stay the same. It's going to stay right where it is. So it's going to drop down. It's going to come up. And it's going to come up through here. And then, where did pi over 2 go? So I'm making sure I hit my points right there. And then it's going to turn around and come down. Okay, so the reddish graph, that's our final answer. So now let me clean up. This is nice doing this digitally. I can clean up easily. Let's clean all of this other stuff out. And what we'll be left with, you gotta be real careful not to touch that line. What we'll be left with is our cosine graph, right? And so let's think about this. Let's think about the points and see how this matches up to what we expected. The cosine of 0 is 1, right? The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And finally, the cosine of 2 pi is, again, 1. And there you go. Right? Now we have one entire period of this cosine graph. Okay. So how about periods? Well, this is nice because the period for the cosine function behaves exactly the same way that the period of the sine function behaved. Right, so to graph this, I'm going to start by saying the period is 2 pi divided by 4, which is pi over 2. So this is pretty tightly scrunched up now. All right, so let's see now. The way I think about this, right, I remember the cosine of 0 is 1. All right, so the cosine is going to start here at 0, 1. And it's going to get to 1 again when it gets to the end of a period. So let's see now. Pi over 2. This is going to be really pretty tightly scrunched up. Pi is 3.1. So pi over 2 is about 1.5. Okay, well let's see if I can keep that x scale. So this is pi over 2, 1, and everything else has to cram in between. All right, so now I'm going to use the same kind of arguments that I used before. With a cosine function, the minimum value is halfway between the two maximum values. Right, so the minimum value is going to be at 0 plus pi over 2 divided by 2, which is pi over 4. Okay, so just exactly halfway between these two, it's going to be down at -1. So that's pi over 4, -1. Okay, now the intercepts are at the middle of the two intervals made by that pi over 4 value. So the first one is going to be at 0 plus pi over 4 divided by 2. That's pi over 8. And the second one is going to be at pi over 4 plus pi over 2 divided by 2, which is 3 pi over 8. Visually, right, it's exactly halfway in between here. So you see this is a very sharp graph. Okay, so let's say I wanted to go another interval, right? Well, then I would go if I'm going to start at pi over 2, let's talk through a second interval here. If I have an interval that starts at pi over 2, where does it end? Where does it start repeating again? Well, the period is pi over 2. So this second period of the graph is going to end at pi over 2 plus pi over 2, which is pi. Okay, so pi is 3.14. That's about here somewhere. Okay, where is my minimum value going to be? Well, it's helpful to just think in terms of the period, right? If it had one minimum at pi over 4, then the next one is pi over 2 units over, right? Let's see, that's going to be 3 pi over 4. Okay, so we have another point here. That is 3 pi over 4, -1. And where are my intercepts? Well, you can think of this either way you want. You could say it's halfway between pi over 2 and 3 pi over 4. Excuse me, this is getting a little cluttered. Just to be clear, I'm looking at this and thinking that was the green point. this point here is pi over 2 comma 1. And the green point here is pi comma 1. Okay, now that's clearer. Okay, so where are my zeros? My zeros are halfway between pi over 2 and pi. So let's see, x-intercepts. Halfway between pi over 2 and pi. That's, let's see, 3 pi over 2. Excuse me, that's not the right value. It's going to be halfway between where the period starts, that's pi over 2, and the minimum value, that's 3 pi over 4. So that's going to be 5 pi over 8. That sounds more like it. So that point there is 5 pi over 8, comma 0. And the second one is going to be halfway between the minimum, that's 3 pi over 4, and the endpoint, that's pi, divided by 2. So let's see, 7 pi over 8. There's my second one. And again, it's a little tricky to draw because it's a very tight graph, right? That's what my graph looks like. All right, so why don't you give this one a try, right? See if you can figure this one out, then we'll go over it together. All right, so I'm going to start just the way I started with the sine function. The period is 2 pi divided by 1/2, which is 4 pi. So I had this happen with the sines, right? I'm going to use the same scale. I'm going to do 0, 2, 4, 6, 8, 10, 12, and 14. All right, get the last one, and that's 16. Okay, so my cosine is going to start at 0, comma 1, and it's going to end at 4 pi, comma 1. So 4 pi, that's 12 plus a little, so that's here, 4 pi, comma 1. The minimum value is halfway between the two. 0 plus 4 pi divided by 2 is 2 pi. So I'm going to go 2 pi, that's about 6, which is here. So that's 2 pi, comma, negative 1. And my intercepts are in the middle, right? So the middle of 0 and 2 pi is pi, and the middle of 2 pi and 4 pi is 3 pi. So it's going to be about here and about here. There you go. There's your graph. Okay. Now, another way we could approach this, right? Another way we could approach finding the intercepts if we wanted to go. I'm kind of out of room to the right. Yeah. So let's see if we can't do another period. This time going to the left. So it'll be -2, -4, -6, -8, 10, 2, 4, 6, 8, 10, 12, 14, -16. Okay, another way to think about how we can find these other values, right, is to use the period. If I wanted to find the next x intercepts, just take the existing ones and subtract a period from them. So pi minus 2 pi is negative pi, and 3 pi, no, sorry, we need to keep going from here. So now subtract 2 pi from this one. Minus pi minus 2 pi is minus 3 pi. Okay, so let's see. This one is going to start at 0, comma 1. It's going to drop down to here. That's negative pi, comma 0. Right? And the next intercept is negative 3 pi, comma 0. So that's about 10, right? That's about there. And my maximum is going to reach a maximum. Remember, we started at 0 and the period is 4 pi. So it's going to start to repeat at minus 4 pi, which is right about here. Whoop, too high though, sorry. I missed. There we go. There is a second period of the graph. And there's your cosine function. Okay, so how about amplitudes? Right? I kind of want to slip amplitudes in here because this is a pretty straightforward change. Again, thinking about transformations, what effect does multiplying the graph, multiplying the function by a number have on the graph? Well, it's a stretch, right? If that was a 2, for example, that would double every y values. So it's gonna go from this to this, right? It's gonna double everything. It's gonna stretch it horizontally by a factor of 2. Right, so let's see what effect that has. Right, and I'm going to do 2 graphs on here. First, let me put in y equals the cosine of x. That's kind of our starting point. Right, that's going to start at 1, 2 pi, 1, 2, 3, 4, 5, 6. 2 pi is about here. Pi is 3 plus a little. That's right in the middle. And let me put a second period on here. It's usually good to do 1, 2, 3, 4, 5, 6 plus a little. It's usually good to do at least 2 periods, just so you can kind of really see the whole graph. Okay, so what does this look like then? It's going to start here, go down and up and down and up. Right? Okay, that's y equals the cosine of x. Now, what does y equals 2 cosine of x look like? Well, that doubles every value. So the point that was here at 0, 1 is now at 0, 2. This point here at the end, this point is at 2 pi, 2. This point, the minimum value that was at pi, -1 is now at pi, -2, and so on. These guys over here get stretched similarly. Now I can sketch my graph. Remember, the x-intercepts don't move because 0 times 2, that's still 0. So it's going to go through the same intercept and up, and then it's going to go through the intercept and up, and then down, and then up. I kind of missed there. Sorry, my graph got a little, well, because I was aiming for the wrong point. There we go. Go through the intercept and then up, and there's your graph. Right? That's all the effect the multiplying by a constant has. Okay, so give this one a try. Think about using one of the cosine negative angle identities first to do a little simplifying. Then try graphing it. Okay, so the first thing I'm going to do is say, look, this is -3 cosine of 2x. I don't have to worry. That's one less negative sign I got to worry about. All right, now we're going to do just what we've done before, right? The period is 2 pi divided by 2, which is pi. So I'm going to start at 0, 1, just like we've always been doing here. 0, 1. Then I'm going to go to pi, 1. And that's the end of the period. So that's the point where I have to be back where I started. All right, so where's the minimum value? Well, halfway between these two is pi over 2, -1. And that, well, let's go the other side, right? Let's go to -pi, 1, and then the other minimum here will be at negative pi over 2, comma 1. All right, now I can get my cosine graph. I'm going to go down and up and down and up. Okay, good. There's what is that? Let's label these, right? This is y equals cosine of 2x. That's just doing the change to the period. Okay, now how about the other ones? Let's see. Multiplying by 3 would take this point from 0, 1 up to 0, 3. So it would be, let me get another color. Right? It would be up here, and this point, the negative pi, 1 would go to negative pi, 3. Pi over 1 would go to pi, 1 would go to pi, 3, and the negatives stretch the same way. Right? And again, the intercepts stay right where they are. And yeah, that got a little fuzzy, but that's okay. There we go. There and there. All right, so that is y equals 3 cosine 2x. Really, I want to make this look at the original. Really is 3 cosine negative 2x, because we saw that negative didn't make a difference because of the cosine negative angle identity. But now I do still have to do the minus sign. Right, so I got to get one more in here. Y equals minus 3 cosine minus 2x. That minus sign flips it across the x-axis. So this point that was at, let me label these. This is negative pi, 3, 0, 3, and pi, 3. Right? The point that was at negative pi over 3 is now at negative pi, negative 3. This point that's at negative 1 flips up to positive 1. 0, 3 goes down to 0, negative 3. All I'm doing is flipping the maximum and minimum values. And I'll use those as my guides. Right? I'm going to start at the minimum, go up through that same intercept, down to the minimum, come up, tag that intercept again, go up to the maximum, go to the intercept, and down. And there's my graph. Now let me clean up. Right? Let me see if I can do this without erasing my blue one. So let me get the green lines out. There we go. Really nice to do this digitally. There. And now let me get the red ones out. And be really careful not to touch the blue lines. There, that's most of the red anyway. Stuff I dare to get close to. There we go. And that's it. Right? That is the graph of negative 3 cosine negative 2x. So, okay, where are we going next? So first, hopefully you're starting to kind of get the idea of how this works, right? I'm going to look at these individual pieces and kind of one at a time figure out what effect they have on the graph, right? And then build it up using transformations and what I know about the sine and cosine function. So we've really got one more major piece to go. We need to talk about phase shifts, right? A phase shift is kind of the trigonometry term for a vertical or a side-to-side shift. So that's what we're going to talk about in the next lecture.